All right, so seeing where proportions can apply to geometry, which is in shapes. We're going to talk about a little bit about shapes today and tomorrow. So we have what's called similar figures. Similar figures is not exactly equal figures or congruent figures. Similar means they have the same shape, but they're different sizes. So one looks smaller, one looks bigger. What you have to remember with this is similar figures, the corresponding angles, which corresponding just means same angles, matching angles, whatever you want to call it, are congruent, which means equal. And then you have corresponding sides, which these are your matching sides. These are proportional, which we'll talk about in a second. So a good acronym to remember is CAPS, C-A-P-S. CAPS stands for congruent angles proportional sides. And the ratio of corresponding sides, which we'll talk about, is something called the scale factor, which is something that will lead you into 8th grade next year. Let's talk about what makes them similar. So we have these two triangles in the picture. Let's talk about the corresponding angles. So corresponding angles means matching angles. Well, if you look at matching this triangle, D matches A, E matches B, and F matches C. So those angles, if you look at how they're labeled, these two lines on D and A, that means that those are congruent, which means equal. E and B both have one single line there, which means those are congruent. And then F and C have 3 lines, which means they are congruent. So again, D is congruent to A, angle E is congruent to B, and angle F is congruent to C. Where we have corresponding sides, these are your matching sides. And what I used to do, or usually do when I'm matching sides, is I like to color code. So for instance, if I look at both of these shapes, side AB is corresponding to DE. They're the same side on a different shape. Whereas if I look at AC is corresponding to DF, so that's how I color code. And then BC would be corresponding to EF. And I just color code that to help me a lot with the math and stuff that we'll see in a second. So what that matters is we're going to find something called the scale factor. The scale factor is like how much smaller or bigger a shape is. So if I look at here, if we're going from A, B, C to D, E, F, notice what happened to the shape. It got bigger. So DEF is actually what we call the new shape versus ABC is what we call the old. And we always want to put new over old when we're finding the scale factor. That being said, if we know that DE matches AB, the new side would be 12 and the old side would be 8. So I put 12 over 8. Well, then we have to simplify. Think about what goes into both 12 and 8. Well, 4 does. 4 goes into 12 3 times, and 4 goes into 8 2 times. So it has a scale factor of 3/2. If I do the same thing for B, C, and EF, then if EF is the new one, that means 9 is my numerator and 6 is my denominator. 3 goes into both 9 and 6. 3 goes into 9 3 times, and 3 goes into 6 twice. That one also has a scale factor of 3/2. If I do the same thing for AC, DF, DF is the new one, so we put it on top, which is 15, and AC is the bottom, which is 10. 5 goes into both. 5 goes into 15 3 times, and 5 goes into 10 twice, which also has a scale factor of 3/2. So that's what it means by scale factor. And if you notice, all 3 have the same ratio, which means that this shape is similar. Congruent angles, proportional sides. That's what proportional means. So let's put it into practice. If I look at my rectangle here, and again, I'm just going to color code for purposes of matching. AD would match EH. And then we have AB would match EF, and then we have BC, which matches FG. And I can leave that 4th one blank just because I already know it matches. Now, if we correspond angles, angle A corresponds to angle E. Angle B corresponds to angle F. Angle C corresponds to angle G, and angle D corresponds to angle H. If we match sides, which is corresponding sides, AB is brown in my picture, which matches EF. And how we show a side is you just put a line above it, kind of like the repeating line of a decimal. BC corresponds to FG, CD corresponds to GH, and AD corresponds to EH. So corresponding just means matching. If we look at the next one, we have, this is where they could try to trick me on any test question, where they will turn the shape to mix match it. So for instance, AC doesn't match DE like it should, it matches DF. So what they've done is they've done the mirror of it. So they've just flipped it over. Versus AB would match EF. And then lastly, BC would match DE. So if I have angle A corresponds to angle F, angle B corresponds to angle E, and angle C corresponds to angle D. If we do matching sides, AB corresponds to EF, they have the same color. BC corresponds to DE, and then CD corresponds to, sorry, I missed something up there. AB, EF, BC, DE, and then C. This should be CA. CA corresponds to DF, so that's a typo on there. All right, now if we want to find the ratio, which means your sizes, let's assume that ABC is the old one, and then DEF is the new one. So I have to, apologies. So I have to put new over old. So I can just pick any side. Let's say I choose side, sorry, that's the wrong number. Let's say I choose side 7.5 and 5. I have to put 7.5 over 5 and then simplify. And we can just do this by division if we want. So 7.5 divided by 5. 5 goes into 7 once with a remainder of 2.5. And then bring my decimal up. 5 goes into 25 5 times. So the scale factor would be 1.5, which we'll talk about more later. Let's do the same thing here. Determine if the parallelograms are similar or what the ratio would be. If I determine that, let's just assume that the first one is the old one and the second one is the new one. So we want to put the new one on top, okay? Which means the new one would be 2 over 5. Can you simplify 2 over 5? No, it stays the same. What about if I did 4 over 10? How can you simplify that? 2 goes into 4 twice, and 2 goes into 10 5 times. And notice that they have the same ratio of 2 over 5, which makes them similar. If I do the same thing on this one, if I know, let's say, assume this one's the old one, this one's the new one. I'm going to do 36 over 12. Those are my matching sides. 6 goes into 36 6 times. 6 goes into 12 twice. I can simplify again. 2 goes into 6 3 times, and 2 goes into 2 once, which equals 3. If I do 8 and 8, so 8 over 8 simplifies to where 8 goes into both, which is 1 over 1, which is equal to 1. Notice that 1 does not equal 3, so this one would not be similar. Just to practice some more, finding the scale factor. If I look at this one, we assume that A is the old and B is the new. So we always put the new over old, which means 12 over 9 and 16 over 12. Well, let's see if it simplifies. 3 goes into 12 4 times, and 3 goes into 9 3 times. 4 goes into 16 4 times, and 4 goes into 12 3 times. Notice that they are the same. So yes, they are similar, and it has a scale factor of 4/3. If I look at number 7, I have to be careful. Let's assume A is the old and B is the new. If 3 matches 5, so it's 3 over 5, and then 5 over 7, can you simplify 3 and 5? You can't, so a check mark. Can I simplify 5 sevenths? You can't, so it's 5 sevenths. But are they the same? No, so they are not similar, okay? Next one, if we assume the A is the old and B is the new, we're going to put 4.5 over 3 and 3 over 1.5. So if we do 4.5 divided by 3, anytime decimals are involved, 3 goes into 4 one time with this remainder of 1. Bring up your decimal. 3 goes into 15 5 times. So this one equals 1.5. If I do 3 divided by 1.5, move over the decimal once. 15 goes into 30 twice. Then this one equals 2. Well, 1.5 does not equal 2, so that's a no there. This one right here, if we assume the A is the old and B is the new, I'm going to put 10 over 8 and 15 over 12. 10 and 8, 2 goes into both. 2 goes into 10 5 times, and 2 goes into 8 4 times. 3 goes into both here. 3 goes into 15 5 times, and 3 goes into 12 4 times. And notice they are equivalent, which means yes, they are similar, and it has a scale factor of 5/4.